doing these problems here for quadratic structures with bridges and arches, right? It's very similar to what we were doing in lesson 5.3, that problem that took us about 15 minutes to do. Based on our grab bag of information, we can easily calculate this stuff from now on. So in this case, remember, every equation that we start with is y is equal to ax squared plus bx plus c, right? Now, let's take a look at our problem for example 5. An engineer is asked to design an arch for a new school building that's based on the equation, which is highlighted, h is equal to negative d squared plus 16, where h is the height in meters of the arch, and d is the horizontal distance in meters from the center of the arch. Now, we need to know how wide that is. Now, basically, if you think about it, the archway is basically, the base of the archway is at height 0. So we're going to let h is equal to 0 here. Now, what that allows us to do is it allows us to go and identify some things. The first thing that I want you to realize is this, that we can rearrange that equation. 0 is equal to negative d squared plus 16 into 16 minus d squared. Now that I've highlighted those two, you'll notice I have two perfect squares. 16, which is a perfect square of 4, and d squared, which is a perfect square of d. Now, based on that, I should be able to go and calculate the perfect, I should be able to factor this because I have a difference of squares. So we're going to get something like this for our answer. Now, solving for this, the long way, you'd go through and you'd end up with the following. Your d-intercepts are going to be d is equal to 4 and d is equal to negative 4. Now, once we've done that, it's asked us, remember, it's asked us how wide this thing is. So let's go and do that. In order to calculate how wide something is, what we're going to do is we're going to take the rightmost value, which is, in this case, 4, and negative 4, and subtract it, and subtract negative 4 from it. And what that'll do is it'll give us a positive value for our distance. In this case, the width of our arches is going to be exactly 8 meters. So, there we go. So we've figured out how wide our arches are. Now, I want you to block this information off and just identify that that is the width of our arch. So essentially, we've got something like this going on. We have negative 4 all the way to 4, and if you looked at the distance between them, you could easily see that it's 8 units apart. In this case, it's 8 meters apart. Now, in order to calculate the maximum height, we're just going to put some information here, right? We want to find out how tall this thing is, right? Now, remember from our last unit, we talked about the axis of symmetry. The last lesson talked about that. That was in 5.4. 5.4 gave us the axis of symmetry for something that looks like this. Y is equal to ax squared plus bx plus c. So if you look at that equation, you've got something that looks like this. So this is what our axis of symmetry is. It's always negative b over 2a. So let's take a look at our original function, this thing here. H is equal to negative d squared plus 16. Now, you could factor it. You could go back and use our factorization and use the intercept form as y is equal to 4 minus d, bracket, 4 plus d, and bracket. Forget that. I don't want to do that. I'm going to use this. Start with our basic equation. This time I'm going to show you this trick. You're going to start with negative d squared plus 16. And what you're going to do right now is you're literally going to take all that information and you're going to use this equation. H is equal to d is equal to 0 squared plus 0 negative d squared plus 0d plus 16. So that means our a is equal to negative 1. our B is equal to 0, and our C is equal to 16. Now, based on that, we're going to use this beautiful equation up here, which will give us the axis of symmetry for this equation. In this case, the axis of symmetry is D is equal to negative B over 2A. By substituting in, you're going to get D is equal to 0 over 2 minus 1, because negative 0 is still 0, isn't it? And 0 over anything is still 0. So the axis of symmetry is D equals 0. Now you know this parabola is opening down because of the negative sign that's on A, the negative 1 that's on A, which means we have a max of h is equal to 16. When we substitute that in, D is 0, we end up with h is equal to 16. Oh my God, that's nothing but the h-intercept, the y-intercept for our graph. So therefore, the max height occurs at 16 meters. And you can say when D is equal to 0. Now, we're almost done. Based on that information, it says, what ranges can D take on? If we take a look at our graph that we have here, our information that we have here, I'm just going to highlight this. Notice, I'm going to go from here all the way to here on my graph. So, basically, the edge point, the very lowest edge point, is -4, and the maximum edge point is 4 along the x-axis or d-axis. So we're going to say something like this for our solution. We're going to say that we have the following. D squared is greater than -4, and D is less than or equal to 4 for our range. Now, basically, if you just think about it, right? This is what our graph looks like. Its maximum's at 16 based on all that information, and it literally moves from -4 to +4. Isn't that what we just showed? So we moved from -4 to +4 inclusive. The equal sign in that thing tells us. The equal sign in those inequalities tells us that. Now, the last part, it asks us to find out how many front doors can be created underneath the arch if each door is 2.5 meters wide. Now, here's the cool part about this. When we did these calculations, I had some of you graph it, but today we're going to do some math, and here's what I want you to do. Some of you guys went and measured the height of the door in the classroom, and you found out that the height of the door in the classroom was 2 meters. Now, what I want you to realize is the following, right? We're going to have to start with our basic equation, and we're going to let the height of our door be 2 meters. And what we're going to do is we're going to find the D values for which this happens. So we end up with D 2 is equal to this stuff here. And now I'm going to take, this is another way to solve for D. If it was 0, you could have done that for the first problem as well. So you end up with, bring the D over to the right side, sorry, the left side. Now you get D squared is equal to 16 minus 2. And then what we're going to do is we take D squared, and you get equals 14. Now, we're going to remove the D squared by square rooting it. And then by doing so, we also got to square root the other side. Now, in order to account for my favorite thing on our parabola, remember, it went from -4 to +4, okay? With a maximum of 16 here along the h-axis. And this was our d-axis, all right? Now, based on all that information, when we go and take a look back at our final problem, our final solution for this square rooted thing here, we end up with D is equal to, well, in order to account for both sides of the axis of symmetry, we have to take a plus and minus for the result of the square root. So we're going to get 3.74 meters for our answer. Now, based on that, you end up with these 2 points, and the height of on our graph is about 2 meters. So now we're going to use that same distance calculation that we did before. We're going to find the width for the width on our parabola that allows for a 2-meter tall door. So in this case, the width is going to be 3.74 minus negative 3.74, which gives us approximately 7.48 meters. All right, for a 2-meter high door. Now, in order to figure out the number of doors, what you got to do is this. You literally go and take the doors that fit. The number of doors that fit is going to equal, well, you take that distance that you have between those 2 points, and then you divide by the 2.5 meter width that we were given. And you'll notice that you get something like this. The width is approximately 2.98 meters. 2.98 doors that will fit. So because we need a full 3 doors to fit, I'm going to say the following. Therefore, only 2 doors will fit underneath the arch. And we're done.